Hi, welcome back to our next set of videos. In this set of videos, we are going to be looking at the properties of real numbers. We are first going to start by looking at our real number system. So we're looking at properties of real numbers, specifically our real number system. So all of the numbers we're going to be looking at are real numbers. And I first want to start off with natural numbers. So natural numbers we're going to represent with the letter N, a capital N. And these are going to be numbers like 1, 2, 3, and all of the counting numbers up from 1. Natural numbers are sometimes called counting numbers because these are the numbers you would say aloud when counting. 1, 2, 3, 4. 700 would be a natural number. 8,351 would also be a natural number. Any whole number that you might say when counting. So these are natural numbers. The next type of number that we're going to look at are whole numbers. Whole numbers are going to be all of the natural numbers, so 1, 2, 3, and up. But whole numbers are also going to include 0. So when we look at whole numbers include all of the natural numbers, but they also have 0. So natural numbers are in the set of whole numbers. When we talk about whole numbers, we're going to use a capital W to describe whole numbers. The next set of numbers that I'm going to refer to are integers. Integers include all of the they include all of the whole numbers, so 0, 1, 2, 3, and all the numbers up from there. But they are also going to include all of the negative numbers. So that means -1, -2, -3, all the way down. So it basically is all of the whole numbers and the opposite of the natural numbers. The negative, if we put a negative in front of all of the natural numbers, all of those would be included. So integers include all whole numbers, which also includes all natural numbers. So if a number is natural, it's also whole and an integer. Not all integers are whole numbers. Not all integers are natural numbers. The next set of numbers we're going to talk about are rational numbers. Rational numbers are any numbers that can be written as a ratio of two integers. So these are ratios of two integers. These are any number that can be written as a fraction or a repeating or terminating decimal. Any repeating or terminating decimal can be written as a fraction. That's why the repeating or terminating decimals are all ratios, or are all rational numbers. Some examples of rational numbers. -3, -2, -1, 0, 1, 2, 3. So all integers are also rational numbers. We can also have any ratio of two numbers. 4/5, -17 over 3. 2,316 over 72. These are all ratios. They're fractions, so they're rational. But this would also include numbers like 0.3 repeating, 0.4712, 19.8. All of these are fractions, repeating decimals, terminating decimals. We could have a number negative 43.128, where the 128 repeats, and that would also be a rational number. So all of these sets, the set of integers, whole numbers, and natural numbers, all fall within the rational numbers. This doesn't quite make up the entire set of real numbers. The rest of the set of real numbers is made up of irrational numbers. Irrational numbers are numbers that can't be written as a ratio of two integers. These are non-repeating, non-terminating decimals. Some examples of some non-repeating, non-terminating decimals or irrational numbers. We can look at the square root of 3. 3 is not a perfect square, so there is no number, there's no rational number that when I multiply it by itself, I get 3. So the square root of 3 is irrational. Pi. Pi is approximately 3.14159, but that decimal continues. So you'll often see this ellipsis after a number, and that means the decimal continues. E is another irrational number that we'll see in Algebra 2. It's 2.718, and it continues. So these are just some examples of irrational numbers. They can be positive or negative. Negative square root of 2 would fall into an irrational number. But I do want to point out that the square root of 4 would be a rational number, so it would appear over there. So this is our set of real numbers, and in our next video, we'll look at a couple examples using them.